Hey guys, welcome to lesson 3.2.2 day 1. Today we are going to get into simplifying rational expressions a lot more than we did yesterday. So let's start with figuring out what kinds of things can cancel in a fraction and what kind of things can't cancel. We kind of started to talk about that yesterday, and we're going to get into it a lot more today so that we can properly simplify these expressions. And we're also going to learn what a hole in a graph is. So for starters, if we have something like this, right, 6 plus 5 over 6 plus 3, you might want to say that the 6 and the 6 cancel, right? It could be tempting to be like, oh yeah, cross these out, but these 6's are stuck in addition and cannot be canceled because of that very reason. Because there's not just multiplication going on here, that 6 is attached to the 5, this one's attached to the 3, so we are unable to cancel anything in this fraction. All right. So the next one, on the other hand, right, now we have 6 times 5, 6 times 3. Because it's just multiplication going on everywhere, these 6's do indeed cancel. Okay, and the reason for that is when you're multiplying fractions, you just have to go ahead and combine the top, combine the bottom, right? You can just squish things together. So another way I could have rewritten this, or maybe this was originally written like this, would have been like this. 6 over 6 times 5 over 3. This would be the same thing as 6 times 5 over 6 times 3. And essentially, this 6 over 6, well, 6 divided by 6 just equals 1, right? So these would have just canceled to equal 1. And that's really what the whole idea of canceling is in fractions. It's the fact that they divide out by each other and just equal 1. And having a 1 there doesn't do anything to the fraction. So the simplified version would just be 5/3. Okay? So this next one, it gets to be a little bit more. And at first, after what I just told you, you might think, well, I can't cancel anything because there is addition going on. However, because we are actually multiplying different terms that are in parentheses, we can do some canceling. And the reason is that we can cancel entire sets of parentheses. So this right here is a 6 plus 5, and here's a 6 plus 5 as well. There's no addition going on between terms because in this case, a term would actually be a set of parentheses. So this 6 plus 5 can cancel with the one on the bottom, and we just end up with 6 plus 3, okay, which of course equals 9, but that's besides the point right now. All right, down here we have x plus 5 over x plus 3. Again, just like the first example, nothing cancels here because there is just addition going on, and we cannot take these x's out of their respective additions. Okay, in this one though, just multiplication, so these x's can divide out and turn into 1, so we would just call that 5/3. And lastly, we can cancel these x plus 5's because this is the situation where there's just sets of parentheses being multiplied together, so these would divide out to 1. All right. Okay. So now let's talk a little bit about what it means to have a hole in a graph or in a rational function. The thing about rational functions is that they can get really funky because of the fact that they have an x on the denominator of a fraction. So if you look closely at this graph, you'll see that at this x value of 1, 2, 3, 4, 5, negative 5, there is a literal hole in the graph. That's not just like a glitchy picture, that's an actual hole in the graph. And sure enough, if you look on the table, you'll see that at negative 5, there's also an error. That's a really, really bad circle. All right, so let's talk a little bit about why this is the case. So if you look at our rational function in the top here, the bottom of the fraction has an x plus 5 in it, okay? And we know from previous years of math that we absolutely are never allowed to divide by 0. So in this case, we're like, okay, well, if we plugged in a number to that would make this bottom 0, that would be an invalid value because we're not allowed to have 0 in the bottom of a fraction. And by testing some stuff out, you could probably pretty quickly realize that -5, if we plugged that in, plus 5, indeed equals 0. So this -5 here becomes a hole in the graph because we're not allowed to use it as an actual x value because it gives us 0 in the denominator. Okay, so that's where you get an excluded value from. Okay, it's any input that results in the denominator equaling 0. Okay, and so we exclude it from the domain, which is why there's an error here. Okay, so anytime you're trying to find excluded values, you just take whatever's in the bottom and set it equal to 0 and solve. Okay, so you end up finding out that your excluded value in this case is -5. All right, so let's do some practice problems that involve both excluded values and also simplifying rational functions. So I have some steps here for you. Whenever you're dealing with a problem where I'm asking you to simplify a rational function, the very first thing you do is factor anything that looks like it can be factored. Okay, sometimes you'll have a problem where you don't need to factor anything, and that's fine. But sometimes you will have to factor something, and when that happens, you have to do it first. Okay, the second thing you want to do is cancel whatever cancels, just like we did on the front here when we canceled stuff. That's your second step. Okay, and then the third step is to talk about the excluded values. So let's take a look here. My first problem, hopefully you would be able to notice that there is no factoring to be done here because it's pretty much already all in factored form. So we can go straight to step 2, okay, canceling the common factors. Well, we can notice that there's an x plus 2 on the top and on the bottom, so these two will cancel. Those will divide and turn into 1. So our simplified expression then would just be 4x plus 1 over x plus 1. This is the simplified version. So that's part of our answer. And now we are going to go ahead and find the excluded values. Now remember what we talked about with excluded values. That is when you take everything in the denominator, all the factors down there, and figure out what would make them equal 0. Now in this case, we have 2. A common mistake I've noticed among students who are finding excluded values at the end is that they don't include the one that we crossed out, okay? And the thing is, even though we crossed it out because we're simplifying, it still is an excluded value, so you do not want to exclude it. So we have to say, okay, well, x plus 2 equals 0, so there's an excluded value there, and then we also have one with the x plus 1. Okay, and again, I got those from these downstairs terms. So if we solve this one, we subtract 2 from both sides, we find that the excluded value ends up being -2. And then if we solve this one, subtract 1 from both sides, find out that the excluded value is -1. So here we will put -2 and -1. All right. And that's all for that problem. Pretty fast. Okay, so we'll actually come back to this one. We'll do it at the end. Let's do this one next. We have 4 times x minus 3 squared over x minus 3. So for this one, we actually want to use the ideas from yesterday and make sure we take into consideration that this x minus 3 is being squared. So let's just rewrite this so that we don't miss anything. If we have something squared, that's the same thing as having 2 of them multiplied together. Okay, so this is how we could rewrite this problem. This way we can see everything and you don't accidentally cross this off and just end up with 4. Okay, that is not what you want to do. You cannot ignore this squared. So once you rewrite it, you realize like, okay, well now I have like an x minus 3 on the bottom and I have one I can cancel it with on the top. So these can go away and you end up with just 4 times x minus 3. All right, but for the excluded values, even though we canceled the bottom, we still use it in the excluded values. So x minus 3, we set that equal to 0. Solve it. It's just like solving zero product properties. All right, so we find out that the excluded values here are just 3. Okay, and now we have this problem. Now this one is a lot more involved than the other two. It involves actually having to factor. This time we actually have to do step 1, whereas in the other two we were able to skip because we didn't have to factor anything. So let's go ahead and box and diamond our way through these two pieces. The thing is, in this problem, both of these need to be factored. Hopefully you would recognize that both of these are in standard form. So let's go ahead and box and diamond both of them. Let's start with the top. All right, and again, I'm not going to go through this too slowly because we have done a lot of factoring. And I have a limited recording time. All right, so x squared on the top, 16 on the bottom right. Diamond, we get a 16x squared on the top and a negative 8x on the bottom. Hopefully you would recognize that you need a negative 4x and negative 4x to make this work, because if you multiply them you get positive 16, add them you get negative 8. So negative 4x, negative 4x. Now we can go ahead and fill out the outside of my box, which will be x and x, and then negative 4 and negative 4. So factored form of the top would be x minus 4 times x minus 4. Now that we have found that, let's just let that hang out on the side for a little bit. We're going to go ahead and take care of the second one now. So the denominator, we got to factor this guy as well. All right, so we have our new box and diamond. All right. So we have 3x squared in the top left, we have a negative 8 in the bottom right, and now we get to do the diamond. Negative 24x squared, again I got that by multiplying the first and third terms. Negative 10x goes on the bottom, and at first you might want to use 6 and 4, but you'll probably quickly realize that it won't actually work. With these numbers you want to use negative 12 and 2. Because negative 12 times 2 is negative 24. Negative 12 plus 2 is negative 10. All right, so now we are ready to fill out the outside of my box. So we have a x and x. You have to think about where to put the 3. If you put it up here, you can't multiply 3 by something to get 2, so that's a no-go. We're going to want to put it here because 3 does go into negative 12, right? So 3 times what equals negative 12? It's going to be a negative 4. So if you multiply these two, you get the negative 12x. And then x times what equals 2x? That's going to be a 2. So our factored form in this one is x minus 4 times 3x plus 2. All right, so now that I've factored both the top and the bottom, what we're going to do is rewrite the equation, or the function, expression, all these things are things we can call it, with the factored form instead of the original form, so we can start canceling stuff. Something you want to watch out for, I see this happen all the time, is people kind of get lost in their work and put them on the wrong side. Like you might accidentally put this on the bottom or something. Be very, very careful. Do not make that mistake. That's going to be sad. Okay, so now that I've rewritten this, I can look at it and be like, okay, well, I can see that these x minus 4s can cancel each other now. So my simplified form is going to be, nope, I want my skinny pen back. X minus 4 over 3x plus 2. This is the simplified answer. And lastly, I'm going to go ahead and find excluded values now. So I'll do that over here. I'll call it EVs. Remember never to ignore any of these, even if we canceled one out. So we have to use the x minus 4 and we have to use 3x plus 2. Do not ignore x minus 4. So we have x minus 4 equals 0. We have 3x plus 2 equals 0. If we solve both of these equations, we get x equals 4 here. Here we have to do a little bit more work. We get 3x equals negative 2. And if you divide both sides by 3, you end up with x equals negative 2/3. So my two excluded values are 4 and negative 2/3. Okay, and that is all for today. Try the problems.